All right, today's lecture is going to be probably the most important concept in this first unit, and that is called dimension analysis. Dimension analysis is simply a method of taking a unit, a measurement quantity. Let's say we've got 1,385 feet, and what we want to know is we want to convert this into how many miles this may be. So dimension analysis, it's not changing the measurement. Once we do this conversion factor, the amount of miles that this is, the distance quantity is equal to 1,385 feet. It's the same value. The difference is it's just in a different unit of measurement. And that's what dimension analysis is. The method that we use is called factor layup method. It's a method that will be very useful when we get towards the middle to the end of this school year, depending on how long all this stuff takes. And we use the same technique when we do something called stoichiometry, which is probably the most important concept overall for the whole year for chemistry students to be able to get mastery of. And that too uses factor layup method. So I really urge you to use factor layup method for all these conversion problems. Now, in order to do a conversion from like feet to miles, as we saw before, you have to first use something that's called an equivalent. An equivalent is what is known to be an equality between this. So we'd have to look up, and again, that's where technology comes in so nice. You can actually look up and Google this. You could say that, You could say how many feet there are in a mile. Does anybody know? I believe it's 5,280 feet. So this is an equivalent. 1 mile is equal to 5,280 feet. So because it's an equivalent, I can use this as a conversion factor to be able to convert my feet measurement into my mileage measurement. Now, just off the top of your head, if you look at this, look at it logically. I've got 1,385 feet. What does that tell me about the answer that I'm going to achieve with this mileage? Yeah, you'll notice it takes 5,280 to equal 1 mile, so I know this number is going to be much less than 1 mile. It's going to be a fraction of a mile of some sort. All right, other equivalents, if you haven't filled these out yet, you can kind of go ahead and pause lecture and see if you can know all these, but I'll go through them. 1 foot is 12 inches. KM stands for kilometer. 1 kilometer. Kilo means 1,000. 1,000 meters. There's 1,000 meters in a kilometer. How many centimeters are in a meter? 100. That's one I think many of you probably already know. 1 meter requires how many decimeters? DM stands for decimeters. There are 10 decimeters in a meter. Liters and kiloliters. 1 kiloliter is equal to 1,000 liters. So through here, we're looking at what's known as a lot of metric system conversions. And the United States is rare. It's one of the few countries that does not use the metric system. The metric system is much easier because in order to convert between these units of measurement, we simply just have to move the decimal point. Versus our system, called the customary system, there's lots of weird conversions, like 12 inches in a foot. How many teaspoons are in a tablespoon? 3. Cups and quarts, who's bigger? A quart is bigger. How many cups equals a quart? Well, 2 cups equals a pint, and 2 pints equals a quart. It's 2 times 2, so there's 4 cups in a quart. There are 4 quarts also in a gallon. So that tells me, another conversion factor, is that there are 16 cups in 1 gallon in the customary system. Okay? So those are equalities. Those are things that we're going to have to look up in order to do these dimension analysis problems. Now, if you look at your chem helper, if you pull it out. All right, so a conversion factor is simply taking that equivalent and creating it, in essence, in a fraction. So if I take the top one, the foot to inches, 1 foot over 12 inches, what I have created is a conversion factor. I can use this conversion factor to convert between foot and inches. However, if I divide the actual length of 1 foot by 12 inches, does anybody know what a conversion factor will always produce when I divide those two quantities to each other? I get 1, because it's the same amount of measurement or the same amount of quantity. It's the same amount because it's an equivalent. And therefore, what I'm doing, when I'm doing a conversion like 1,385 feet to miles, when I'm converting there, because I'm in essence is using a conversion factor, I'm multiplying by 1, I'm not really changing the number. All I'm doing is changing its unit of measurement. It's the same quantity, however. And that's the key concept to understand with dimension analysis. It's the same amount, just a different unit of measurement. With every conversion, with every equivalent, we could write it as two different conversion factors. I could have also I could have wrote this number as 12 inches over 1 foot. So for every equivalent, we can create a conversion factor where we have one over the other or vice versa. Both of them, however, still are an equivalent of 1. Okay. Now, which one do we use? Well, that's when we start doing these dimension analysis problems. So now I'm going to go ahead and start doing some example problems for you to do. And again, once you kind of get the hang of it, you want to stop the lecture and then go ahead and try to do the next one and come back to it. That'd be great. All right, so we have 1.5 meters. So the first thing we do in a dimension analysis problem is we write down the given amount. The given amount is always the one that we have the number with it. So I'm starting with 1.5 meters and I'm converting it to centimeters. So what I need to do that is I need to utilize a conversion factor, an equivalent that goes from meters to centimeters. Well, if I look up above, I'll notice that I do have an equivalent of 1 meter equals 100 centimeters. Now in factor label method, this 1.5, it's like putting it at the top, in essence. Okay, there's really nothing on the bottom, and sometimes people will cross it off or they'll just put like a 1 here. But I'm starting with 1.5 meters. To get rid of meters, I could write an equivalent where there's either meters on the top or meters on the bottom. How do I know? Well, if I want to get rid of the unit of meters, if I put meters on top, we'd be multiplying. And when I multiply meters by meters, I don't cancel out. What I get is meters squared. Just like you did last week, that would give me a unit of area. So to get rid of meters, I have to put it in the opposite orientation. So to get rid of meters, I'm going to put meters on the bottom, and I'm going to put what I want, centimeters, on top. You'll notice when I do all these problems from here on out, I always put my units in first, I put my numbers in second. This is something I really strongly urge you to do. Okay? So now I look up my equivalent, and my equivalent says 1 meter is 100 centimeters. So I fill in. There's 1 meter is equivalent to 100 centimeters. So I'd want to use the equality with the meters on the bottom because I'm starting with it and I want to get rid of it. Because I have meters on top and bottom, they're going to cancel. In essence, what I'm really doing is taking 1.5 meters, timesing it by 100 centimeters, and then I'm dividing it by 1 meter. Well, because I have a meter divided by a meter, those units of measurement cancel. I'm left with centimeters, which is exactly what this is showing here. So you'll notice that I always do units first. I cross off the units when I'm done converting them, and then I do the math. So if the numbers are on top, we multiply. If they're on the bottom, we divide. If it's a 1, I just ignore it because multiplying or dividing by 1 means the number really hasn't changed at all. So 1.5 times 100 gives me 150 centimeters. So what this tells me now is 150 centimeters is the same length as 1.5 meters. It's the same thing. But now I've converted it from meters to centimeters. All right, the next one. If you want to go ahead and give this one a try, go ahead, pause the lecture, and see what you get. 127 grams. We want to convert grams to decagrams. So again, because we're starting with grams, to get rid of it, it's going to go on the bottom. Whatever unit we start with, that's the next unit on the bottom. Decagrams on top. Okay? So now, do I have that conversion up here, up above? I do not, so I'm going to go back to the number. So I know 1 decameter, it's further left on that little conversion sheet, is equivalent to 10 grams. It takes 10 grams to equal a decagram because deca is 1 step to the left. Okay? Grams will cancel. And now my calculator, 127 times 1, or we can ignore that, divide it by 10. Okay? 12.7 decagrams. Okay, how many centimeters are in 1 foot? Now, you could go online and Google and search what's the equivalent to foot to centimeters. But I told you right here that 1 inch is equal to 2.54 centimeters. But I'm starting with a foot. So in this problem, you might make use of two conversion factors. I'm starting with foot, so to get rid of it, I put foot on the bottom, or feet, however you want to say it. And because I want to use this conversion factor of inches to centimeters, I want to finish off with centimeters, I might first try to convert foot to inches. Now I know some of you would just skip this step because you already know that there's 12 inches in a foot. But what I'm just showing you here is how we can, if we don't know a specific equality, we can use multiple equalities to get to the same endpoint. Okay, the foot cancels. That would give me the same measurement of length into inches. And then whatever's on top becomes the next unit on the bottom. And this is where now, when I'm looking at equality between inches and centimeters, I can use the equality that's given. 1 inch, the equality says, is equal to 2.54 centimeters. And what I'm left with is a unit of measurement in centimeters. So now I'll pull my calculator. 12 times 2.54. The rest of the numbers are 1, so I'll ignore them. Since they are both on top, we multiply. And we get 30.48 centimeters. Okay. Number 4, how fast is a runner going in miles per hour if he is running the 100-meter dash in 10 seconds? Well, first of all, if I'm going to miles per hour, this is a speed or velocity unit of measurement. Right now I know a distance and I know a time. To get velocity or speed, velocity is distance divided by time. Remember back to algebra classes. So if the race is 100 meters and it takes 10 seconds for this runner to run it, their velocity, their average velocity throughout the course is 10 meters per second. Now, whenever we have a per quantity, I always get in the habit of writing meters over seconds. This means meters per second. Now, we're going to have to do a conversion factor to convert from one unit to the next. Now, you'll notice that it's meters per second, but now I want miles per hour. You'll notice that I'm changing both the top unit of measurement, the distance from meters to miles, but I'm also converting the bottom unit of seconds to hours. So this is going to require me to do two conversion factors. The first one for the distance and the second one for time. So to get rid of meters, I'm going to put it on the bottom because it's on top. I always put in the opposite orientation to get rid of it. I'm going to replace that distance unit of meters into miles. Okay? They've told me here that 1 mile is 1.609 kilometers. I'm going to cross this out. I would give it to you in meters, which is 1,609 meters. So 1 mile is equal to that. So I can fill in now. 1 mile is equal to 1,609 meters. And the meters would cancel. Now, if I were to stop here, if I were to take 10 and divide it by 1,609, that would give me a velocity in miles over seconds, or miles per second. But I don't want that. I want miles per hour. Okay? To do the next conversion factor, I got to convert seconds into hours. Now, this is why I wrote it as a fraction, meters over seconds. You'll notice that the seconds on the bottom. To get rid of it, I would have to put it in the opposite orientation. The seconds would have to go on top because I'm replacing the bottom seconds with hours. So now, how many seconds are there in an hour? We know hours are much longer than seconds. Does anybody know? Well, there's 60 seconds in a minute and there's 60 minutes in an hour. So there's a total of, not 120, but 3,600 seconds. There are 3,600 seconds in an hour. Now the seconds, because there's one at the top and the bottom, that cancels. And now you'll notice that my units is going to be miles per hour. So now in my calculator, I take 10. Because 1,609 is on the bottom, I divide if it's on the bottom, and I multiply if it's on top. the ones I'm ignoring, because if you multiply or divide by 1, it doesn't change the number. So now I'll take my calculator out. 10 divided by 1609 times 3600. And I get 22. Oops. Oops. 22.4 miles per hour. Okay, so this runner's running really fast. It's 100 meters in 10 seconds. That's almost Olympic caliber. It is Olympic caliber. So this is really fast. Okay, for a runner. So that's how we do a conversion when we have both a unit on top and bottom, and we're trying to change both of them. Okay. All right. Okay, like the first one, 1.5 meters to 100 centimeters. When you probably took your math class, your math teacher probably just simply said, okay, since centi is 2 to the right, we move the decimal point 2 to the right. And that works fine when we're doing problems like this when we're using the metric system. But when we're using some of the customary system where it isn't factors of 10, the only way of getting them right is to use the factor label method. So I strongly urge you to use the factor label method for all of them. And then if you do have a metric, in your chem helper, there's a section right in the middle. It says chem is try. Right off to the left of it, there is this prefix system that I have written up above. Big M ... KHDA. Okay. These are the prefixes attached with the metric system. The big dot you'll notice in the very middle is much bigger than the other dots. This is called the base unit. What are we measuring the material into? For example, if we're doing a distance measurement in the metric system, what would be the base unit? We'd be measuring things in meters. So this is where I would have meters, would be in that position. That's the base unit, that's the starting point. If it's time, we measure things in seconds. How about mass? Grams. Volume. Liters. These are the units of measurement that we will be utilizing whenever we are doing a problem with distance, time, mass, or volume, which those are the 4 typical ones that you see most often in just about any type of problem. Now, when I add a unit to it, if I move over to the right, this is the prefix D, which is deci. You'll notice I put the other parts of it below it. So a decimeter would be a quantity of measurement that is 1 move to the right. Okay? And we'd abbreviate decimeter as DM. So the first letter is typically the prefix, the second letter is the base unit of measurement. That's how it typically is. Then you notice all of these have got one letter to symbolize that positional, that movement, that prefix unit, except one, and that's DA. Okay, DA stands for deca. It's the only prefix you have to be worried about that actually has 2 letters with it. So if I have a decameter, it's not DM because we've already used D for deci. Decameter would be DAM. Okay, not a dam, but a decameter. Okay, so that's the only unit of measurement. Be careful of the prefix that has 2 letters associated with it. Now, in this, how we've organized these units of measurement, these prefixes, the farther we go to the left, the larger it is. The further we go to the right, the smaller it is. And that's important in order to create these equalities. The base unit does account for a decimal move. Each time I go, if I move once to the right, like from the base unit meters to decimeters, okay, we can figure out what the equivalent is. How many of each are equal to each other? Well, the unit that's furthest left is the largest one. So that's the one that I put a 1 with it. So I know meters is bigger than a decimeter. So then 1 meter is equal to a certain number of decimeters. And that's dictated by how many times I've got to move to the right to go from the largest unit to the smallest unit. And we'll notice to go from the base unit meters to the decimeters, it's only 1 move to the right, which 1 move to the right equals 10. So I know the equality is 1 meter equals 10 decimeters. Okay? If you notice some of these dots that's between, like big capital M and K, those dots actually stand for a prefix unit of measurement, but they're units that are so infrequently used that you don't have to worry about them. But if I want to go from a megaliter to a kiloliter, okay, and again, we have a lowercase m for milli, we have a capital M for mega. Not quite sure then why they just didn't do a capital D for deca, but that's what they've done, okay? So, to get this equality, who's bigger, a megaliter or a kiloliter? A megaliter is. So I put 1 with mega, and now I count how many times it takes me to go from the big M to the K. We do have to count the dots, so to go to mega, it's 1 decimal move, 2 decimal moves, 3. So, because it's 3 decimal moves, it'd be 3 zeros. So there are 1,000 kiloliters in a megaliter. Okay? All right, let's try one more. Let's go from hectoseconds and convert that into microseconds. Hectoseconds to microseconds. Okay? Go ahead, stop the lecture a second and see if you can get it right. All right. Hecto is bigger, it's further left, so 1 hectosecond is equal to a certain number of microseconds. To move, 1, deca again only sounds for 1 prefix move. 1, 2 to the base, 3, 4, 5, 6, 7, 8. So there would be 8. 1, 2, 3, 4, 5, 6, 7, 8. There would be 8 zeros following the 1. Which means I would have 100 million. There are 100 million microseconds in a hectosecond. And if you don't like putting all those zeros, we could use scientific notation. Since it's 8 moves, it'd be 1 times 10 to the 8th microseconds. So these are equivalent units. And now we can use these equivalent units in what's called a conversion page. And if I look at it, I can see that deca and grams puts me here. They're 1 move away, so that tells me it's a factor of 10, and deca is. Who's bigger, a meter or a kilometer meter? Kilo is further to the left. I did with you guys some conversion. So here are a few more example problems to do and try. So now what I would do is I try to pause my lecture, and I would try to do these problems, and then when you're done, to check your work over, see what you get, and see if you get the correct answers. Okay, so pause lecture now and give the next one a try. Okay, so we have 36.2 miles per gallon. So whenever we have a per quantity, I'd want to write it as 1 unit over the other. Now I'm trying to convert this into kilometers per liter. Okay, so first of all, we have miles and kilometers. And on the previous page, it said there's 1.609 kilometers in 1 mile. Okay, so to get rid of miles, where would we put it? Hopefully you said bottom. I want to put it in the opposite orientation so I can get rid of it. I'm replacing the miles with a kilometer. Okay, so now I fill in with my numbers. There's a 1 in front of the mile, and there's a 1.609 in front of the kilometer. Now if I were to stop here, this would give me kilometers per gallon. Okay? All right, next thing, you'll notice that they gave me an equality of liters to quarts. They didn't give me an equality of gallons to liters. But do we know how many quarts there are in a gallon? Well, if you look at the previous page, now gallons is on the bottom. How do I get rid of it? Where do I put it, top or bottom? Hopefully you said the opposite orientation. If it's on the bottom to get rid of it, we put it on the top. Okay, how many quarts are in a gallon? There are 4 quarts in a gallon. Now, gallons would cancel, and this would give me a measurement in kilometers per quart, but I don't want that. I want kilometers per liter. But now I can convert the quarts into liters because I got that equality. So quarts is on the bottom. To get rid of it, I put it on top now. Liters goes on the bottom. In front of the liters, there's a 1. In front of the quart, there is 1.057. Quarts cancels, and I'm left now with kilometers over liters, which is what I want. Okay, so now I take my calculator out. 36.2 times 1.609, divided by 4, multiplied it by, it's on top, 1.057. 15.4 kilometers. Okay. What is the speed of 550 meters per second into kilometers per minute? Okay, again, we're changing both the top unit from meters to kilometers and seconds to minutes. So again, this is going to take 2 conversion factors or more potentially. Okay, so to get rid of meters, it's on top. We'll put it on the bottom. We're replacing it with kilometers. If I go back, so it's bigger. So 1 kilometer is 1,000 meters. If I were to stop now, this would give me kilometers per second, but I want kilometers per minute. Seconds on the bottom, to get rid of it, I put on top. I'm going to replace it with minutes. Minutes is longer, so 1 minute is 60 seconds. Now I'm ready to go ahead. 550 divided by 1,000 times 60. We get 33 kilometers per minute. Okay. All right, in the choice system measurement, you can see what all these units of measurement were. How many grains are in 45 pounds? So I'm going to write 45 pounds. You'll notice in this conversion factor, all of these are odd numbers. Whenever we are not in the metric system, we just can't simply move the decimal point. Now, some of the earlier problems, you can always do that metric conversion and then just check it by moving the decimal and see if you get the same answer. It's a great way of checking your work. Okay, so the first thing we can do is we can convert pounds to ounces. Since pounds is on top, to get rid of it, put it on the bottom. Ounces on top. I now plug in my numbers. 1 pound is 12 ounces. But I don't want pounds, I want grains. So then I always get rid of the unit, so I know I no longer have it. It's gone. So now I can go from ounces to drachms. 1 ounce is 8 drachms. If I were to stop here, this would be how many drachms are in 45 pounds. Not done yet. Now I can go from drachms to scruples. There are 3 scruples in a drachm. Not done yet. We want to go to grains. Scruples on top to get rid of it. So whatever's on top becomes the next thing on the bottom. Okay. So now I take 45 times 12 times 8 times 3 times 20 equals 259,200 grains. For those of you that are the archers in class, who shoot archery, a lot of you might have your arrow weight is in grains. You might shoot an arrow that's 300 grains, 350, 400 grains. That is still a unit of measurement we have all the way back dated hundreds and hundreds of years ago in England. Grain is actually a unit of weight, just a very light weight. Okay, so that's kind of how you can now take your arrow that's 300 grains, and you can then convert that into pounds, utilizing these same units of measurement. Now, some of you might look at this and say, "Well, that's a lot of work. Couldn't I have ever seen that 1 pound is 12 and 1 is 8, and could I just have simply have multiplied these numbers together?" And the answer is yes. If I take 20 times 3 times 8 times 12, I get 5,760. What I've done now is I'm creating a new conversion factor utilizing all this information. What this tells me is that it takes 5,760 grains to equal 1 pound. So you can sometimes use and converge multiple conversion factors together to get one neat conversion factor if you want that to do a problem. So you could either do either way. In essence, you still get the same number. Now I'd take 45 times 5,760 grains over 1 pound, and I still get the 259,200 grains. The very last problem I'm not going to go over with you. It's a challenge problem. I am going to post it in Canvas for those of you that'd like to try this, an extension, and see if you can actually get it right. Excuse me. This is utilizing multiple conversions, but it's one that I think that's fun, and for those of you that really do enjoy math, it might be one that you find challenge and exciting to go out and try and see if you can get it right. Okay? All right, so that's how you do factor label method. If you have any questions, please come talk to me as soon as possible. This is one that I know some of you are going to really struggle with. It's very important that you start doing practice problems, and if you can't do them because you just don't quite understand, there's other lectures out there that you can always Google more lectures on how to do factor label methods, some more videos. But if you are struggling a lot, please get a hold of me, and I'll try to find a time that maybe we can talk together face to face, that we can kind of clear things out if you are really looking at and struggling with these problems. Okay, so now I'd like you to go ahead and do the homework set. Actually, I have you watching the video one day. You can do the homework set tomorrow. If you want to do it right away now, that's fine. And then when you finish that homework set, please submit it and get it done by the end of this week. All right? Again, thanks for listening.